In our first video, we went over how to find the area between two curves in its simplest case. This time, we're going to look over a few ways that it can get a little more complicated. So with this first shape, it's really just an extension of the shape that we used in that video. These are the same lines, but we're looking at a broader area. We want to find not just that middle area, but the ones on the left and right as well. And this becomes a little complicated because, as you can see in the first section, the red line's on top, in the second the blue, and the third the red again. So one integral doesn't quite cover it for this whole section, and instead we'll have to split the integral into parts. Essentially, we'll have to find the integral of the first section and the second section of the third just completely separately, treat them as their own problems. So in order to do that, we're going to have to find these intersection points, which are the same as they were before since these are the same equations. So we know that this line is x equals -1, and this one is x equals 3. So then we need to set up our integral, starting with this leftmost region, -2 to -1, and this time the red line's on top, so it will be our f of x, and the blue line will be our g of x. And then we'll add that to our original integral for that middle section that we solved in the last video. And then back to the red line being on top. From there, it should be relatively to solve using integration. Just remember that this integral and this integral are really the same, so you don't need to bother solving it twice. Just solve it once and then use different a and b's. The middle integral, of course, we already solved for in the previous integral. So that's how you would approach that problem. Now this is a different kind of complexity. We could solve it using the same approach from above by splitting right here, but in this case it would actually be easier if instead of going from top to bottom, we could go from left to right. Because from left to right, the red is always on the left and the blue is always on the right. It avoids the complexities of having to split the integral. But how would we do that? Well, we would have to integrate using dy, not dx. So we would have to put everything about this in terms of y. Our a and b, instead of being the x-coordinates of the leftmost and rightmost intersection, are now the x-coordinates of the bottom and top of the shape. So we'll have to find where these two equations intersect. And to do that, we set them equal to each other. Start by squaring both sides. And then we'll get everything on one side and factor. So we know that the x values of these coordinates must be -1 and 5. However, since we're in terms of y, the x part of the coordinates doesn't actually help us. We need the y part of the coordinates. So we're going to have to put this back into the original equation in order to find them. So when x is -1, y must be -2. So we have one point of intersection. And when x is 5, y must be 4. We have a second point of intersection. And to come back and just label them real quick on our graph, there we go. So we have an a, -2, and a b, 4. Now we need our fy and our g of y. So if we can't do top and bottom, which is f and which is g? Well, the rightmost equation is always going to be your f of y. If before we were integrating from top to bottom, we're now integrating from right to left. So x minus 1 is going to be our f of y, and, oh, wait, that was my bad. everything has to be in terms of y, which means so does our equations. We need to set them equal to x and put them in terms of y. And the same goes for this red equation. So I'll give myself a little room here. Let's see, y squared equals 2x. I'm just squaring both sides. I'll subtract the 6 and then divide by the 2. And there we go. So still, the blue line is our rightmost equation, so it goes first. Y plus 1. And then our red equation in terms of y. And from there, it's a pretty simple integral. You can stop the video here if you have what you need, but we'll go ahead and solve it for completion's sake. I'm just distributing the minus sign and simplifying a little bit. So we can see here that the plus 1 and the plus 3 are going to combine, so I'm going to go ahead and do that and make plus 4. A little cramp there, but it's okay. And since this is y's and dy, it's straightforward, regular power integration rule. So y squared, and then divide by 2 plus 4y. And this y becomes y cubed, and you're going to divide by 3 times 2, you get 6. Negative 2, 4. So when we put the 4 in, I'm just going to cut that off there. 4 squared is 16, divided by 2 is 8. 4 times 4 is 16. 4 cubed is 64. Subtracted, and negative 2 squared is 4, divided by 2 is 2. Negative 2 times 4 is negative 8. And negative 2 cubed is negative 8. So positive 8 divided by 6. And now we'll go ahead, distribute the minus, combine some like terms, and let's see what we get. 8 plus 16 is 24, minus 2, 22, and then plus 8, so 30. And then we still have this minus 64 over 6, and minus 8 over 6, which becomes minus, let's see, 72 over 6, which is just 12. So 30 minus 12, and that is, let's see, 18. So the area between these two curves is 18. All right, everybody, have a good day.